Assalamualaikum and a good day everyone. My name is Ahmad Shukri bin Saifuddin, and today I will present my Six Sigma DMAIC project entitled Reducing Customer Waiting Time at Campus Cafeteria. This project focuses on improving a common service problem that many students and staff experience during peak lunch hours. This slide introduces the main concept of Six Sigma DMAIC. DMAIC is a structured improvement method that helps us move to step by step from identifying a problem until controlling the improved process. Instead of making decisions based on assumptions, DMAIC encourages us to use data and a proper analysis before suggesting solutions. Six Sigma in service operations. Although Six Sigma is commonly used in manufacturing, it can also be applied in service operations. In this project, the service issue is waiting time at the cafeteria. Waiting time is important because when customers wait too long, it affects their satisfaction and their overall experience, even if the food is a good quality. DMAIC roadmap for this project. So this slide shows the overall roadmap of the project. The define phase explains what problem needs to be solved. The measure phase identifies the current performance using data. The analyze phase finds the root cause of the delay. The improve phase proposes suitable solutions, and the control phase ensures the improvement can be maintained in the future. Project case overview. For this study, the selected process is the campus cafeteria lunch service. The problem usually happens between 12 p.m. until 2 p.m. when many students and staff buy food at the same time. The main goal is to reduce the average waiting time to below 8 minutes so that the queue becomes shorter and the service experience becomes better. Project case overview. For this study, the selected process is the campus cafeteria lunch service. The problem usually happens between 12 p.m. until 2 p.m. when many students and staff buy food at the same time. The main goal is to reduce the average waiting time to below 8 minutes so that the queue becomes shorter and the service experience becomes better. Now I will move to the first phase, which is the define phase. This phase is important because it sets the direction of the project. Before collecting data or proposing solutions, we must first understand the actual problem, the customer needs, and the project boundary. Problem statement. The main problem is that the customer experiences excessive wait time before receiving their food. This causes long queues, congestion near the counter, customer dissatisfaction, and a pressure on the service staff. Therefore, the goal is to reduce the average waiting time from 12.8 minutes to below 8 minutes while still maintaining the food quality and the service accuracy. Step 2. Voice of customer. The voice of customer helps us understand the problem from the customer's point of view. Customers are not only complaining about the long waiting time, they also face unclear queue lanes, food availability issues, and a slow payment. This means the improvement should focus on both speed and service clarity. Step 3. Project charter. The project charter is used to keep the project focused and control. The scope begins when the customer enters the queue and ends when the customer receives the food. Items such as menu pricing, supplier contracts, and a kitchen renovation are not included because they are outside the project scope. This helps ensure the project remains realistic and manageable. SIPO, High Level Process View. The sideboard diagram provides a simple overview of the cafeteria service process. The suppliers include food vendors, cashiers, kitchen staff, and the cafeteria operator. The process includes choosing the menu, joining the queue, making payment, and collecting food. This diagram is useful because it shows how different parties contribute to the final customer experience. Define phase deliverables. At the end of the define phase, the problem, customer needs, project boundary, and the target have been clearly established. This is important because it prevents the project from becoming too broad. It also ensures that every improvement is linked directly to the main issue, which is reducing customer waiting time. Next, I will move to the measure phase. In this phase, the purpose is to collect data and understand the current performance of the cafeteria process. Without measurement, we cannot know how serious the problem is or whether the improvement is successful later. Step 1. Measure plan. The main measurement used in this project is a waiting time, which is measured from the moment the customer joins the queue until the customer receives the food. Other supporting measurements include payment time, queue length, and a defect count. In this project, a defect is defined as any customer who waits for more than 10 minutes. Step 2. Baseline waiting time data. The baseline data was collected over 5 lunch periods with 30 customers observed each day. From the data, the average waiting time is 12.8 minutes, which is higher than the target of 8 minutes. Out of 150 customers, 81 customers waited more than 10 minutes. This gives a defect rate of 54%, showing that the current service process needs to be improved. Step 3. Waiting time trend. So this trend shows that the average waiting time exceeded the target on the every observed day. On Friday, it recorded the highest waiting time at 14.2 minutes. This shows that the issue is not random or isolated. It is a repeated problem during peak lunch hours, so a structured improvement is necessary for this problem. Defect definition and a baseline capability. For this project, the defect rule is simple. If a customer waits more than 10 minutes, it is counted as one defect. Since more than half of the observed customers exceeded this limit, the cafeteria process is not capable of consistently meeting the expected service standard. This proves that the problem must be analyzed further. Measure phase interpretation. The measure phase gives 3 important findings. First, the average waiting time is too high. Second, the cafeteria missed the 8-minute target every day. Third, the defect rate is 54%, meaning that many customers waiting longer than the acceptable limit. Therefore, the next step is to analyze where the delay comes from. Now, I will move to the analysis phase. This phase focuses on identifying the root causes of the long waiting time. The purpose is not just to see that the queue is long, but it is to understand why the queue becomes long. Step 1. Current process map. The current process shows that the customer arrive, read the menu, join one queue, order, pay, wait, and collect food. The main weakness is that all customers are placed in the same queue even though their needs are different. Customers who want ready meals and the customer who need more time to decide are mixed together, which slows down the whole process. Step 2. Pareto analysis of delay causes. The Pareto analysis shows the most frequent causes of delay. The top causes are single payment counter, menu decision delay, and a food replenishment delay. These causes contribute most of the recorded delayed incidents. Therefore, Improvement should focus on these major causes first because they have the biggest effect on the waiting time. Step 3. Fishbone diagram. The fishbone diagram helps organize the possible causes into categories such as people, method, machine, material, environment, and a measurement. For example, the method issue includes no express lane, while the machine issues include only one payment terminal. This shows that the waiting time problem is caused by several connected factors, not just by customer volume. The 5-way analysis payment bottleneck. The 5 ways analysis is used to go deeper into the payment bottleneck. Customers wait because payment takes too long. Payment is slow because all customers use the same cashier lane. This happens because ordering, payment, and a pickup are not separated properly. The root cause is the absence of a clear peak hour service flow standard supported by the waiting time measurement. Root cause summary. Based on the analysis, the 3 main root causes are single queue, payment delay, and a manual uncertainty. This means the main customer is related to the process flow design. In other words, the cafeteria does not only need more speed, but it needs a better system to separate customer flow during peak hours. Next is the improve phase. This phase focuses on selecting solutions that are practical, low cost, and suitable for the cafeteria environment. The improvement should reduce waiting time without affecting food quality or service accuracy. Step 1. Improvement alternative. Several improvement alternatives were considered. An express lane can separate ready meal customers from custom order customers. A pre-order menu board can help customers decide before reaching the counter. A second payment option can reduce cashier bottleneck, while a replenishment trigger can prevent popular food from running out too late. Step 2. Solution Selection Matrix. The solution selection matrix compares each solution based on the impact, ease, and cost. From the matrix, the selected package is the pre-order menu board, express lane, and a replenishment trigger. This combination is chosen because it has strong impact, it is easy to implement, and does not require high cost. Step 3. Future State Process. The future state process improves the customer flow by separating different types of orders. Customer first view the menu board, then choose the correct lane. Ready meal customer use the express lane, while customer order customers follow another service path. This reduces congestions because customers are no longer forced into one single queue. Predicted improvement impact. The expected result shows that the average waiting time can be reduced from 12.8 minutes to 7.4 minutes. This is about 42% reductions. Most importantly, the predicted waiting time is below the target of 8 minutes, which means the proposed improvements meets the project objective. Implementation Plan. The implementation plan explains how the improvement can be carried out. The cafeteria supervisors prepares the menu board, service staff manage the express lane, the manager assigns payment support, and a kitchen staff use the replenishment trigger card. Each person and a success indicator, making the plan easier to monitor. Now, I will move to the final phase, which is the control phase. This phase is important because improvement is not only about making the changes once. The new process must be monitored so that the cafeteria does not return to the old single queue problem. Step 1. Control Plan. The control plan sets clear standards for the improved process. For example, The average waiting time must remain below 8 minutes. The express lane must be open during peak period, and the menu board must be updated before 11:30 a.m. Each control item has a person responsible and evidence, such as a checklist or record. Step 2. Monitoring dashboard. The monitoring dashboard uses a simple color system. Green means the waiting time is below 8 minutes and the process is under control. Amber means the waiting time is between 8 and 10 minutes. So, the supervisor needs to check the queue balance. Red means the waiting time is above 10 minutes and immediate corrective action is required. Step 3. Standard operating checklist. The checklist turns the improvement into a daily work routine. Before peak hour, staff update the menu board, place queue signs, and prepare popular items. During peak hour, they monitor the queue and keep the express lane open. After peak hour, they record the waiting time and review the top delay cause. Reaction plan. The reaction plan explains what action should be taken when a problem occurs. For example, if the queue exceeds 15 customers, backup payment support should be open. If ready meals are unavailable, the kitchen should prioritize top-selling items. This plan helps staff respond quickly before the waiting times become worse. Risk and sustainability. There are several risks that may affect sustainability. Staff may forget to open the express lane. The menu board may not be updated. Demand may change according to class schedules, and a customer may ignore lane instructions. To sustain the improvement, the cafeteria should assign checklist ownership, review data weekly, train staff, and use a clear visible signs. Conclusion. In conclusion, this project shows how DMAIC can be used to solve a real service problem in a structured and a practical way. Each phase contributes to understanding, improving, and controlling the cafeteria waiting time issue. DMAIC Project Summary. In the define phase, the waiting time problem, scope, and the target were clearly identified. In the measure phase, the baseline average waiting time was found to be 12.8 minutes. In the analysis phase, the main root causes were single queue, payment delay, and the manual uncertainty. In the improve phase, the selected solutions were menu board, express lane, and a replenishment trigger. Finally, in the control phase, the control plan, checklist, and a reaction plan were established. So these are the references used to support the DMAIC methodology and improvement tools in this project. The references include source related to DMAIC, fishbone diagram, Pareto analysis, and a queue management. That's all from me. Thank you for your attention.